Okay, let's start this journey of Unit 3 factors and products with a throwback all the way to grade 6. Yes, I know what you're saying. Grade 6, that was the best 10 years of my life. Oh yeah, oh good for you. Okay, remember this? Composite numbers and prime numbers. Do you remember that at all? I do. I remember a composite number, for example, like a number like 6. I used to do this and go, oh, there's a 1 and there's a 6 and make that little rainbow. Do you remember that? Yeah. And then I would go 2 is to, oh, 3, and there's a little rainbow. And then I notice the next one up is 3 is already there, and I don't need to do anything. So I found out that 6 actually has 1, 2, 3, 4 factors, making this a composite number. Aha! So what did a prime number mean? A prime number is a number that has exactly 2 factors, which includes 1 and itself. Okay, so that's kind of interesting. Like the number 7, for example. 7, if you try to do that rainbow thing, is just 1 and 7. That's all you've got. 11 is another one. 1 and 11. That's, again, all you've got. 3 is another one. But here comes a question that I'm sure is going to have some kind of great discussion at the supper table. Is 1 considered to be a prime number? Well, if you look at the definition says you have to have at least 2 factors. 1 doesn't have 2 factors. 1 only has itself. 1. That's it. Okay? So 1 technically is not a prime number. Oh, that ought to get some good heated discussions at the dinner table today. So let's look at something called prime factorization then. Prime factorization is taking any kind of number and writing it as a product of prime factors. That's what you're after. So you're going to be dealing with composite numbers here, and you're going to write this out as a product of prime factors. I've got an example for you. 5,500. So there's 5,500. Now, I know what you want to do. You right away say, oh, well, that's an even number. That should be divisible by 2. And then you're going to put a 2 here, and you're going to get another big number, and then this is going to break down by 2, and give you another big number, which is going to break down by 2, and you're going to have one of these factor trees at about 4 kilometers long. Well, that's kind of silly now, isn't it? What I want you to do is I want you to use a little bit of your brain here. Yes, brain power, okay? And here's what I want you to do. Realize that 5,500 is actually, look, a factor of 100. There's one of your factors right there. There's the 55. Now, it's easy making this a breakdown of just 5 and 11. This is going to be 10 and 10. And look, you got 2 prime numbers already, this one and this one, but this still breaks down to 2 times 5. This breaks down to 2 times 5, and bring these guys along with you. And there's your prime factorization of 5,500. Now, if you want to be really cool and be one of those kind of people that they talk about at the math parties all the time, realize that you've got a 5 here, a 5 here, and a 5 here, which in fact is 5 cubed. You have a 2 here and a 2 here, which in fact is 2 squared, leaving you with 11. That's another way of writing this prime factorization with powers. Okay, now I've got another question for you. Here's the question here on the left. 2646, a really easy question to do, isn't it? You know right away, I was saying earlier, do not use just 2's. But wait a second. You may just have to use 2's. Because look what happens. If I go 2646 and divide that by 2, look what happens. I get an odd number. Uh-oh. Uh-oh. So this looks like it's going to be 1323 times 2, giving me this odd number, and you right away think, oh my goodness, is that prime? Well, actually, no. What I want you to get into the habit of doing is I want you to think, okay, if it's not divisible by 2, try the very next number. Try multiples of 3. Try 3. Try 9. Try 27. See what I'm doing? I'm going by 3's. I'm going 3 to the 1, which is 3. 3 to the 2, which is 9. 3 to the 3, which is 27. I want to try something bigger so I can make this number a little bit easier to deal with. See what I mean? So let's try. Let's try dividing this by 27 and see if that, in fact, works out to be a nice number. And lo and behold, look at that. 27 and 49. This is 27 and 49 times 2. Those two numbers are so much easier to determine the prime factors of than dividing by 3, dividing by 3, dividing by 3, and getting this huge factor tree, which is kind of boring. Okay, 27, you know, is 9 times 3. Okay, 49 is 7 times 7. Check this out. Look at that. You're almost done. Check this out. Okay, 9 is 3 times 3. There's the other 3. There's the 7 from here. There's the other 7 from here. There's the 2. And there's your prime factorization of 2646. And again, if you want to be considered really, really cool, you might want to put this in terms of powers. 1, 2, 3. This is 3 to the 3 times 1, 2. 7 to the 2 times 2. There it is as powers. And this is just a beautiful way of learning how to do factor trees.